In this lesson, we're going to be looking at the concept of ratio. Let's go ahead and look at the definition first. A ratio is a comparison of two quantities. Now, there's lots of different quantities that you can compare. Let's start by taking a look at a couple visual examples. The question says, what is the ratio of blue squares to white squares? Now, when you compare these ratios, you need to be sure to read the statement and determine which one is first. And it says blue squares, so we're going to be comparing blue squares to the white squares. So when we set up our ratio, we're comparing the blue to the white. So we'll start by counting the blue. 1, 2, 3, 4, 5, 6, 7. There are 7 blue, and we compare that to 1, 2, 3, 4, 5 white. So the ratio of blue to white would be 7 to 5. And we write it with these two dots here that identify 7 to 5. Over here in this example, same question. What is the ratio of blue squares to white squares? If we count them, we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We have 28 blue squares. And we have 1, 2, 3, 4, 5, 20 white squares. Now, you'll notice this ratio is 28 to 20, but if we were to reduce these numbers, it would actually be the same ratio here of 7 to 5. So technically, these two examples are the same. We'll be talking in the future what that means. But that's two visual examples of a ratio. Let's take a look at a couple statements here. These are all three ratios as well. This one is a classroom, and it asks specifically about the number of girls to the number of boys. And in this particular classroom, there are 15 girls and there are 10 boys. So we could write the ratio as 15 to 10. The opposite, the ratio of the number of boys to girls then would be 10 boys to 15 girls. It can also be written as a fraction. You can see here we've written 10 over 15. And of course, that is a fraction that reduces to 2/3. So specifically in this classroom, if we were to be asked about the ratio of boys to girls, instead of saying 10 to 15, we would say 2 to 3. It's basically just a fraction reduced. In this third one here, the same classroom, it asks about the number of girls to the total number of students. Well, if there's 10 boys and 15 girls, we add that up and we have a total of 25. And there were 15 girls, so the ratio is 15 to 25. We write it as a fraction, 15 over 25, and again we reduce that and it becomes a fraction of 3 over 5. So in this classroom, the ratio of girls to the total number of students would be 3 to 5. Now let's look at a couple practice problems. This statement here says that a basketball team has 20 wins and 10 losses. What is the ratio of wins to losses? Again, always remember what you're starting with. We're comparing wins to losses, or if we were to write it as a fraction, it would be wins over losses. Now, the number of wins is 20, and the number of losses is 10. So it's 20 to 10, but again, we would reduce those numbers, and actually they have in common a 10, so really it would be a ratio of 2 to 1. So for every 2 wins, there's 1 loss. So again, it's a ratio of 2 to 1. Let's look at another practice problem. This problem here says that the school flagpole is 42 feet high and has a 6-foot shadow. So what is the ratio of height to the shadow? So again, I'm going to write my ratio. I'm comparing height to shadow. And the height of the flagpole is 42 feet. So I'm going to start with 42. And I'm going to compare that to the shadow, which is 6. If we write it as a fraction, it's 42 over 6. You'll notice that this is what we might call an improper fraction, and it could be reduced. 6 goes into 42 7 times, so we might write it as 7 over 1. So technically what we have here, we have a ratio of height to shadow, which is for every 7 feet of the flagpole, we have 1 foot of the shadow. So the ratio would be 7 to 1. That is the concept of ratio that we will be discussing this week.